Cool. So seems we don't have a lot of people today. But anyway, so my name is Lidi. So today, Saurabh and I will basically talk about the configuration management and the resource tracking at Pinterest. So when we talk about the configuration management, it's more about the machine configuration management here. Okay, so first, this is an introduction about the Pinterest. So as some of you might know that we just very recently we announced that we exceed 200 million monthly active pinners. And so to support these 200 million monthly active users, so this is basically the graph on your right, my left, is basically represent our infrastructure. So every circle here is actually represent a service. So we have hundreds of services, and the size of every circle actually represents how many instances we are running for this service. So right now, we are in the mixed stage. So some of our services are running in the Docker container. Some of our services still running in the EC2 instance, so it's a mixed status. And but essentially, all of them are running on the AWS today. So both Saurabh and I are from the cloud management platform team at Pinterest. So this is our team. And so the challenge of our team is to build a platform for the Pinterest engineers. So our customers are Pinterest engineers. And we build the platform majorly focusing on three things. The first is developer velocity. So our goal is we can build a platform that engineer can use to efficiently deploy, roll out their changes, and also it also includes all the developer tools they can use. And we built the service framework, which is developer use how to write their microservice in the Pinterest environment. The service framework handles all the metric, the logging, and even service discovery, and how to do the high availability for it has the client side detection, do the retry, and for the service quality. And the third part is efficiency and governance. This is the main topic about today. It's the third part. So because we are running to support 200 million users, you need a fairly large size of the infrastructure. And we have a very big bill from the Amazon. And how to run this infrastructure, and we are faster growing, so you can see our server fleet size increased very significantly month by month and year by year. And running these things very efficient is essential for our finance. And to reach the efficiency, governance is also a very important fact to manage how we can run this infrastructure efficiently. So here is I'm not sure how many of you are using AWS. Okay, so probably everybody basically familiar with what's the EC2 instance management. So this is what essentially I'll give you very quick about. EC2 is a virtual machine AWS provided, and you can launch an instance from admin console, command line tools, or the API. And as the growing of the Pinterest we are in a situation that essentially at the beginning, everybody start to launch their infrastructure by themselves. Some people go through the command line, some people build their own provisioning tool, some call the API, all kind of things. And as time going by, when our size of the organization grows, it's become harder and harder to find out who launched this instance and control the size of the fleet. And also, everybody needs to handle, for every EC2 instance, you have the placement information about the region, availability zone, and the placement group you have to deal with. And meanwhile, the network and the security. So ideally, you should have one centralized controlled place for the entire company to launch the instance. I think in general, let everybody go to AWS and directly launch an instance is not the best practice. And but in the faster growing company, this is usually harder because you always have the other high priority job to do. So we are gradually converging to the more governance mode so we can control the EC2 instance management. But when we build our configuration management system, we must take into account the fact that we don't have a centralized control place to control how people launch instance. So when you're running an infrastructure in the cloud, it gives you a lot of things. And these three things is, from my personal experience, I feel is most different from how to run the traditional data center infrastructure. So first is elastic. Unlike in the old way that you have to order a machine, which it takes 2 weeks to arrive at your data center, it takes you find all the right network cables, mount it to the rack and connect to the network, start to paving the base image. You are being able to basically launch the instance just with one button click, and this is really powerful. And the second thing, it gives you the much better visibility compared to you running a traditional infrastructure. If you operate on the traditional very large data center, it's very difficult even to do your supply chain management. You have to manage all the machine income and all the machine retire and a lot of things. Right now, it has all the API, you can grab this information. And the third part is now you pay by your usage. And combined with elastic, this means quite different with the traditional model, because even Amazon has a fairly it has a complicated pricing model for you to figure out the best optimized model. But essentially, you pay by your usage, and you can launch the instance. And I think everybody know about auto-scaling today, and we heavily use it. So these all are the new things, new requirements. You need to build the things in the cloud, compared to what in the traditional data center you don't have these things, and so probably the purpose will be different. And also it brings the new challenges here. So the first I would say is infrastructure is much more dynamical compared to what you have before. For us, every day we launch many instances, we terminate many instances. This majorly came from 3 results. So first, we do auto-scaling for many of our service, and basically at the peak time they launch, I think our size between the peak and the non-peak time is probably, we can have 200 to 300 difference between our peak and the non-peak times. And also, for some case, when we do the deployment, we do this, the green-blue type of the deployment. For some of our service, we tear down the entire old cluster and we launch a new cluster first, and make sure move the traffic, everything's good. Then we tear down the old cluster. During this process, a lot of new instance has been launched, and a lot of old instance has been terminated. And the third part is for our AMI rotation. So we regularly upgrade our base image for the AMI is Amazon machine image. We regularly upgrade our base image for the AMI. Whenever we make an upgrade for AMI, we need to refresh our fleet. So this also results a lot of instance termination and launch. So the second challenge you have now is do the usage tracking for the sharing account. So AWS give you some usage information and some of the basically breakdown for your billing purpose, but it's basically done in the account scope. And normally in the company, it's you have a lot of account sharing across multiple teams, and they share the same VPC. They're running things on the same subnet for the ease of the development. But that means you have to do some usage tracking inside the account so that you can distinguish the organizational usage for each of these kind of resources. And the third part is complexity for the optimal efficiency. I mean, before you are running the cloud, it's relatively easy to compute your I mean, how much you're going to pay for your infrastructure, because you have a very static infrastructure. Now you have to consider the complexity here, for mainly coming from the reserve instance and on-demand instance. So I guess you all know about the Amazon pricing, about reserve and on-demand. So you get a big discount for the reserved, and but you have to pay ahead. When you're not using it, you still pay for it. And but on-demand, you shut down, you don't pay for it. But because your traffic has a peak pattern and a lower pattern, it's very hard to get the right amount because load always change. And so basically we have to, it's harder, all these dynamics combined with the pricing model, it's harder for your efficiency to decide what's the right size. I mean, we have, right now, every month, we basically look at our historical. We try to reserve certain of the instances. Usually, we reserve a little bit below what our actual usage, so we still have some buffer, a little bit of buffer for the on-demand. But it's definitely not the best we can do, but to get the best, there is some complexity there. So for the configuration management, so basically, this is a several sample question we try to answer. We're building a system to try to answer the questions like this, like how many instances of a specific type are running in our infrastructure right now, and we have different team pick their own EC2 instance, and so we run quite different type of the instance here, and also very frequently we're going to check what's the IAM role of a given instance, and also we will check about the version of the software we are running, and it's a typical questions that we want our system to answer. And so the first thing you come here is why we just not using the AWS API to answer all these questions. There are several limitations for the AWS API, makes this be very hard. The first is the rate limit. So Amazon has a rate limit for their management API, which the threshold is pretty low. I mean, if you run considerable scale on AWS, you will often hit this. They recommend you can bump this a little bit, but it's not going to handle very high QPS. And second is AWS, especially for the EC2 instance, it's only give you the current running instance and probably some most recent terminated instance because they haven't recycled them. And so you have no history and you have no terminated. And we have some finance tool and our chargeback system. We want to look back a monthly data. So we need the history and the terminated data to show that. So the third part is that it has very limited support on how to extend the data model for the EC2. EC2 give you a tag, which is essentially a key value pair. And but it's not very quite friendly when you want to extend the schema to support a lot of different things. And in our system, we also track all the, not only the EC2 information, but all the software, all the packages we installed on this AMI, we built in this AMI, and all installed by our deployment system and the Puppet. It could be thousands of the packages. So we hope there's a better extending data model. And the first part is there is no aggregation API. So EC2 only allows you to do some filtering query. You cannot do the more advanced aggregation and the better, better conditional filtering here. So, and the last part is EC2, AWS API is not very performant. In our case, it takes several minutes basically to get all the running instances we have. And we have quite a few systems that are doing this very frequently, so we want a more performant system. So because of these limitations, so we build our own configuration management database. So we want it to be more scalable, and can handle higher QPS. So we pick the Elasticsearch as our main storage, which it can scale pretty well. And basically you can add the new field and extend it. And it has pretty decent support for the aggregation. And our system can handle much higher QPS compared to AWS. We have many hundreds QPS right now. And also we store the entire history for every instance we have launched and terminated. And also we have some cron script running on every host, every instance we have. They will upload all the detailed software configuration to this database. So from a single place, you get all the view from the machine management and to the software package installed. And last thing, it's much better. It has much better performance compared to AWS. To get all the running instances we have, it just takes a few seconds. So this is basically the high-level goal we want to build. So we want to build a single source of truth for hardware information, software information, and the configuration-related information. And it wants to support the engineers can do some ad hoc query on this system. And then we have a security team regularly do all the scanning for our infrastructure. We have a finance team basically regularly pull the data and build all kinds of finance report. And we have a lot of infrastructure tools here. Actually means a lot of our infrastructure provisioning system, our deployment system, our HBase deployment, MySQL deployment, they are looking at this database. So they don't directly talk to the EC2 to get the information. Because of many of our infrastructure rely on it, it must be very high available, and of course it must be performant. So this is roughly a high-level architecture of these things. So we have 3 components. We have worker, whose main responsibility is to do the data collection. So basically, we have in the EC2 we have a lambda function, which basically gets the CloudWatch events. This basically shows the detailed graph. So we have the lambda function basically triggered by the CloudWatch events. Right now we look at the instance launch, stop, and terminate events. And whenever these things happen, it triggers our lambda function. Our lambda function will basically create a message and put it into a SQSQ. And our worker will basically subscribe to the SQSQ and do the notification processing. So when it gets the notification, it actually make a EC2 call to get the information, because the CloudWatch event only gives you the instance ID, which has been terminated, launched, or stopped. And we have a zookeeper, which basically to manage inside the worker, we have dozens of background job running actually, and there are several important ones. Basically, zookeeper is played as do the leader election and do the locking for us. And we have an API, which basically we provide a RESTful API, which our automation tools and our host info uploader always talk to this. And we have a UI, which is a searchable UI. Our engineers go to there to query all the infrastructure information they want to know about. So I think I've covered this. So this is the worker. So the worker basically, besides the SQS subscriber, I listed all the other important components there. So first is we do instance tagging and sync. So we attach some tags to our instance to reflect our organization information. And also we sync this tag regularly back to the EC2. So EC2, if you look at the EC2 instance tags, it also contains our own labeled organization tag. And also we do the AWS reconcile. Reconcile means every certain amount of time we will dump our entire running instance. We'll compare to what's in the database, do a reconciliation. This is fairly important for us. So first is because there are 2 major reasons. So the first reason is that we only get the notification for the instance launch, terminate, and stop. There are many other instance attributes that can be changed. And there's no notification, no available CloudWatch event to generate it. So you have to have a way to regularly sync this from the AWS. The second thing is AWS sometimes, because its API has some eventual consistency, it does not return you it may not return you the value when actually you get the notification. So you need something to regularly sync it. And the third one is we do the AWS status sync. Status sync is about the actual instance status, their health check, whether the instance is in repair, something like that. And also we have uploaded our snapshot to some external store. And so basically we take a daily snapshot and upload it, which have a summarize of all the information, includes the instance launched this day, running this day, or terminated this day, and we send this to our external storage for some external reporting purpose. So this is our worker. So this is talking about detail about how we deal with the event consistency. So EC2 API essentially gives you a maturized view from many different sources inside the AWS. So for example, when you receive I usually see when you receive a running instance, you make a EC2 call. Many of the information actually are not there at the moment you receive the events, which usually a few seconds after you receive the instance notification. And then it can take, my observation is it can take a few minutes. It will be available, and you have to retrieve there. And but there are some attributes that are pretty critical to us. So to work around this problem, so we have to always keep waiting. So basically, our approach is that we receive the message, we make an EC2 call, and we look at all the important information we want there. If they are not there, we will actually put this message back to the SQS queue with a kind of exponential delay algorithm there. And then later we pick it up, and we only delete the message from the SQS when we think all the critical attributes we have are available. And also, the reconcile process I have mentioned, this reconcile process can help us to sync the rest of the non-critical attributes, and also it helps us whenever we enter some unpredicted state or our server has some failover, it will always guarantee us to return to the right state. So for everything I'm talking about, actually we open source a version which trimmed our specific Pinterest-related infrastructure stuff, but all the worker, UI, and API, we have these things open sourced on the GitHub, and we actually also ship together a Terraform file. You can use it it will provision the Lambda, the SQS, everything there. You can directly run it. And this is basically our UI, how it looks like. This is also the same UI our engineers basically to check their status and their instance. So besides what we're talking about, there are several other use cases where our deployment system, visibility, MySQL H-based permission control, it's all using. So CMDB is a very core piece of our current infrastructure. Supposedly nobody should directly talk to EC2, everybody should talk to this database. And so you can see all the pieces are rely on it. So now I'm going to hand over to Saurabh to talk about the infrastructure cost management.
All right. Hello, everyone. I'm Saurabh. I work with Lidi on the cloud management platform team. And I'm going to extend what Lidi just mentioned. So as you can see, we have multiple use cases for CMDB, one of which is deploy system, visibility systems, our databases like MySQL and HBase. But we also have this major use case, which is called as infrastructure cost management. And like the most important reason why it is useful for us is because the scale at which we are growing, it is extremely crucial to figure out which services, which jobs, or what is using our infrastructure. So I'm going to talk a little bit about how we achieve this and how we figure out where we spend money on our infrastructure. So if you think about infrastructure cost management, these are a couple of questions which usually come up in any organization, which is which is the fastest growing service week over week. So given your infrastructure, you need to figure out that, okay, given in this specific week, which was the service which grew over 5% or 6% in its usage of infrastructure. The second most common question is, given any service foo, what is the infrastructure cost of running it? And what I mean by infrastructure cost is it's not just the cost of EC2, but maybe you run some data jobs under it, or you store some S3 data under it. So all of that contributes to the cost of running the service foo. The third question might be that it's not just about the service. So we in-house run our own Hadoop platform, which is run on top of EC2. Now, what is the cost of that, or how much infrastructure do we need to spend on it for the next month? So all of these are kind of questions which need to be answered by our infrastructure cost management console, and we built it as an extension of CMDB. So just general other questions that are very similar to like the ones which I previously mentioned. Okay, so what we built is a system called as Chargeback. The goal of this system is to track the infrastructure spend for every service, for every data job that you run. And the goal is that eventually we want to answer a question that given any project, what is the resource footprint of it across all the platforms? And these platforms mean EC2, they mean container platforms, Hadoop platforms, streaming platforms, all of them. So we track all of this data at a workload level granularity, which is long-running services, Hadoop jobs, Spark jobs, and in terms of bucket storage, we track S3 bucket prefixes up to level 3. So this is how our infrastructure console dashboard looks like. This is the kind of information or view that most of our teams get. So it's scoped out per team, and you can see your current bill for this given month. And you can see a pie chart of how much you spend on your compute, how much you spend on your Hadoop jobs and S3 jobs. And also you can see a week-over-week growth of how your infrastructure has grown. So this is like literally the view of my team, and we can see that we are spending more on data jobs. So something like this is extremely powerful, and it gives your team a lot of information on what is being spent, and it helps us in deprecating workflows or deprecating services that we don't use. So how did we achieve this? So I'll just go through the flow of how we did this for long-running services or microservices, and we did similar things for other systems such as Hadoop platform and even the Spark streaming platform. So we observed that right now we run all of our services directly on top of EC2. We do not use any container platforms. So the way we run it is we basically pick the service and we right-size the instance so that we can run the service on top of it efficiently. But the property that all of the services have is that each service runs on a specific host. And we use this information to leverage and basically track the number of hosts that a specific service is running. But the challenges in the cloud environment again show up, which is like an instance was up for half an hour and then it went down. So how do we aggregate the usage of all the instances for a given service and basically come up with a cost of running a service on a given day? So the chart that Lida showed you, this is actually not just the hosts that we run a specific service on, it is actually the cost of each service that we run. And it depends upon the instance type, which basically dominates how much cost each service costs us. So how do we get there is basically for each given instance that we run on EC2, we set a project tag. And project tag is nothing but an AWS label that we set. And the way we set it is basically all the places where we launch instances from, so that can be our cluster managers or Terraform scripts. All of these places basically set an AWS tag called project onto each of these hosts. And CMDB has a background reconciliation job which runs and basically keeps syncing all of this data back into our CMDB data store so that all of the instances have this specific tag called project. And it is a mandatory tag which we make sure that it's set. Otherwise, we mark that instance as shame, which is essentially saying that the instance is either not launched correctly, or we need to go back and figure out who has launched this instance and set its respective project tag. Because without this, there is no way we can track which instance is used for which service. Then the next concept that is extremely useful in metering the costs is a concept of end-of-day snapshots. Now, why is this needed is because, as you know, in EC2, instances keep going up and down, and they can start and stop at any time. So what we do is that considering AWS removes all the host information and tag information once an instance is terminated, it's not very useful for us to ping AWS API and get all of this information because they don't have it. But since CMDB has this, we could leverage this. So the end-of-day snapshot essentially has all the hosts that even ran for a minute on that specific day. The next part is when we think of services and their costs, we think of it in instance hours. So what is an instance hour? An instance hour is literally the number of hours a specific instance ran in any given day. So for example, if a service runs on 2 hosts, on first host it ran for 6 hours, on the second host it ran for 4 hours, then that specific service essentially consumed 10 instance hours. And the reason why we finalized instance hour as the metric is because if you think of AWS instances, depending on which family type they belong to or depending on which instance type they belong to, they are either CPU or memory dominant, and there is this back and forth about whether we should meter things in terms of CPU or memory. So instead, we just figured out that we could track the services usage in terms of dollar cost. And the way we come up with dollar costs is given instance hours into the instance type cost, it yields us the cost of running the service on that specific host. So we literally use this like 5-step formula where you iterate through all the instances that we have in a specific end of day snapshot. And you say that if the host has a project tag belonging to a specific service foo, then calculate its instance hours, multiply it with the instance type cost, and just keep adding that to the total cost of running that service. So this way, with this literally these five steps, we can calculate what is the cost of running a service on that given specific day. So this is the kind of infrastructure console dashboard that we have. So as you can see, we have 3 separate tabs. One is for compute VM, which is essentially EC2. We have a tab for S3 and a tab for Monarch, which is our Hadoop platform. And you can see like how each service is tagged separately. You can see which instance types it's running on, how much instance hours are being spent, and of course the dollar amounts I have removed for privacy reasons, but you can see the level of which we can get information about. So there is this concept of two-step chargeback. So if you think about any platform that Pinterest runs, let's say you can think about a container orchestration platform or a Hadoop platform, those instances or those platforms run on top of EC2, but at the end, just saying that a platform's usage grew by X% is not enough, because there are some other teams or some other members who launch data jobs or launch containers on top of it. So you need this kind of 2-level metering. But essentially, all of that happens exactly in a similar way, where you basically first calculate the cost of running the platform, which is essentially the instance cost of running it on top of EC2. And then you do the second level of chargeback, where you track each job that runs on that specific platform, compute its cost, and then you take a delta, which says, okay, the platform costs us this much, but the jobs that execute on top of that platform are costing this much. So the delta should be very bare minimal to make sure that we run our platforms efficiently. And therefore, for all of these, the underlying data storage that we need is essentially CMDB, because without EC2 costs, we can't meter anything above it. So why such an infrastructure or cost management system is necessary is because the first step is we get a good view into the cost and daily infrastructure usage. It is extremely critical for capacity planning and reservations, because the finance team needs to figure out how a service is growing, what is the capacity that we might need for the next few months. And this data is extremely critical and useful once we have it. This is also used for forecasting the growth of platforms or services. So there are some critical services that we run within Pinterest, and we want to know how they're growing with our organic growth in terms of users. So such a data is useful even for forecasting the growth of services and platforms. And it is also useful in deprecating unused services. So when, let's say, there is a service which was deployed a couple of months back, and now you're running a version 2 of it, most of the times it happens so that there is not a good workflow for deprecating old services. And since that service is still getting metered and it keeps showing up in the console, it provides some visibility which makes sure that people delete them, otherwise the teams are getting charged for it. And it also helps us in resolving the issue around ownership attribution, where we don't know who is running a specific service or which project that specific service belongs to. So all of these questions are answered by the infrastructure console. And I just showed you an example of how we do it for long-running services, but we do a similar thing for other workloads, let's say for Hadoop jobs or S3 prefixes as well. So having said all of this, the current setup is not the most ideal one. We would definitely want to reiterate and improve on it. So the most obvious and the immediate thing that we need to do is that given all our platforms, so we run Hadoop platforms, we run container orchestration, we have EC2. So we need a scheme of unifying how we identify the resources and their usage across all of these platforms. So we are working with different teams to figure out how we can unify the creation of such identities and their ownership in a single place. So essentially that boils down to creating a centralized place where you can provision these identifiers for any type of workload that you run. It can be a long-running service or a Hadoop job. And of course, a very useful or a powerful tool that we might have in future is automated notifications for unexpected growth. So when you see a specific service growing beyond, let's say, 2% or 3%, we want the users to be automatically notified about it. So this is the track where we are going in terms of resource cost tracking. And that's it. Sure. So, so the way we do it is we do it in 2 steps. So first, as I said, like there are platforms that run on top of EC2, and then there are jobs or containers that run on top of those platforms. So we do this 2-level chargeback. First, we figure out what is the organic growth or the slope of the growth for that specific platform in terms of EC2. So that helps us in capacity planning for that specific platform, where we know that, okay, for our Hadoop platform is growing at 5% month over month. So we can kind of predict how the specific Hadoop platform is growing. And on top of it, we know that even though Hadoop platform is growing 5% week over week, there is a specific search project which is contributing to 15% of that 5%. So the second level of chargeback helps us in figuring out that, okay, for search specific infrastructure, we need to ramp our infrastructure by X%. So the 2-level chargeback is what is the most critical part in figuring out how we plan or predict future, but it's essentially extrapolating our current slope. Yep.
I have another question.
Sure.
So I'm just curious why you choose Elasticsearch as the
Correct. So there are multiple reasons why we chose Elasticsearch. The first is we often saw that the way we query the data store is not by ID or an object. It's mostly around filter of tags. So for example, give me all the instances that have MySQL version X, or give me all the instances with this specific instance type, or give me a count of the number of instances running a specific instance type. So all these aggregations are essentially better done in Elasticsearch instead of other storage. So
I'm not sure if for this filtering, I think MySQL can do pretty well. It's just like say where something equals to a string, MySQL should do pretty well.
sure, but yeah.
In general, it's very difficult to figure out. So first, because we actually put everything in the history, and we have many instance launch, scale up and down. So the size is actually a little bit bigger for the SQL if you don't have the right index. And also for every computer, it's not because SQL you have a flat data model, and it's quite different to do the join. You cannot be a very flat model because it's more like you have many different settings of the embedded. So every machine we store quite a lot of the information, and overall, so basically this is the main reason we come to even we are using the Elasticsearch. We actually the most pattern is basically it's ease of the development. Don't have to worry about the index creation and the size growth, and because we have I would say we store too many information for a host sometimes.
Yeah, I agree with you partially, but I think you have this system. If it's just event based, so just message maybe Elasticsearch is a good choice. I think Elasticsearch is probably not good for the daily reconciliation because there's a lot of updates. It's not good for.
You mean for?
I don't know what's your experience in the daily reconciliation. There are lots of updates going on.
Oh, we do more than daily reconciliation. We do.
Involves lots of data updates.
I think generally if you put to the batch, it's fine. It's fine because you only do the reconciliation for your running instance. I mean, for running instance, it's not that much. And so we basically do the reconcile and create the batch update. It's generally fine. I mean, even our store document size is pretty big, which contain everything from the day when the system launched. But the only thing you changed is this running instance or this recently terminated instance.